Hello, you're welcome to Maths Clinic Series. In this video, we are continuing the series of trigonometry. And this time, we are going to look at trigonometric ratios. Trigonometric ratios. By the end of this short video, you should be able to identify and define trigonometric ratios, compute the tangent, sine, and cosine of an acute angle in degrees, solve questions involving sides and angles of a right-angled triangle. So, in the first video, we said that trigonometry deals with measuring of angles and sides of a triangle. And I told you that I'm going to concentrate much, or trigonometry normally concentrates so much on right-angled triangle. Even though other triangles are also involved, but we are going to basically work more on right-angled triangle. Now, with trig ratios, there are three of them. We have the sine of an angle, the complement of sine of an angle, which we normally call the cosine, then the tangent of an angle. And so each of these has got their definition. Basically, we are saying that they are all simply one side of a right angle triangle divided by another. That is what defines trig ratios. So let's go detailed and see each of them. Now let's have our right angle triangle like this. And we measure from the point here to the point here is called B. From the point here to the point here is called A. And then that of the side, that's the longest side, is called C, which we call the hypotenuse. Now, if I use sine to define this particular angle, the acute angle here, then we'll say the acute angle is defined. If you're using the sine, we divide the opposite side of the acute angle over the hypotenuse side, and that will give us the sine of an angle. So more or less you can say sine theta is equal to B over C. What it means is that if I know the definition or the measurement for the B, and I know the measurement or the side for C, and I divide B by C, the result will be the sine of the angle. What if I use cos to define it? It will give me adjacent over hypotenuse, and that will be BA over C. And if I use tan, it will be opposite over adjacent, and that will give me tan theta as B over A. So these are the three ratios and how we can calculate their value in terms of finding the angle. So tan theta will give us the B over A, cos theta A over C, and then sin theta B over C. How do we remember that? Anytime I'm working on sin theta, I should divide opposite over hypotenuse. And how will I remember that? If I'm doing the tan, I should divide opposite over adjacent. And that is why the scientists or the mathematicians came up with this acronym, SOHCAHTOA. And it is almost everywhere in the world. Everybody uses SOHCAHTOA. What does that mean? If I say so simply means using sine to define the angle, and for that matter, I will only divide opposite over hypotenuse when I say so. And if I say ka, it means I'm dividing adjacent over hypotenuse. And if I'm saying toa, I'm dividing opposite over adjacent. So this will help you remember what to divide over what in order to get a ratio of the trigonometry. Now let's look at other trig ratios that we normally use, which of course we are going to use that mostly with relative math, not in core math. But then we need to mention it. We have what we call secant of an angle, cosecant of an angle, and cotangent of an angle. Now talk of secant of an angle or secant of an angle, we are taking the ratio, the reciprocal of the cos. If I know the cos of an angle and I reciprocate it, I will get the secant of an angle, which we call sec theta. Then if I reciprocate sine also of an angle, then I get complement of the secant, which we call cosecant or cosec theta. The same thing if I take the reciprocal of tangent of an angle, I will get cotangent, which is called cot theta. So these are three other ratios we use in finding angles of a triangle. If you are doing elective maths, you'll be doing more of this in trig identities. Before we end this video, let's take one example of how to use SOHCAHTOA in solving a triangle question. So we'll take example number 1. The remaining examples will be handled in our next video. In this question, the question says find the value of the side marked x in the diagram. So we want to find the distance for x. That of the A to C has been given as 12, and B to C is not given, but the angle is given here. And having angle and having one side, we can always find the missing side. So we can calculate for this, and we can also calculate for that. But for now, we want to find the value of x. And so what do we do? Now, ask yourself, what do you have? You have an angle, which is theta. And we have one side, which is hypotenuse. And we are finding the adjacent of the angle. This is the angle. Its adjacent is here. Sorry, its opposite is here, and adjacent is here. So we want to find the adjacent. So if that is the case, if we use SOHCAHTOA, which of the SOHCAHTOA will give us H and A, or A and H, which comes as A and H? So if you look at SOHCAHTOA, if you see TOA, we don't have A and H, and if you see SO, we don't have A and H. The only time we have A and H is Ka. So we are going to deal with cos. So we can start by saying cos of theta is equal to, then how do we define cos? Cos says Ka adjacent over hypotenuse. So since we know the theta, we want to find cos 60. All right, so cos 60 is adjacent of the cos 60 here, or sorry, adjacent of the 60 here is our x, and its hypotenuse is 12. And so we do cross multiplication in order to make x the subject. Let me shift it here so that my image will not distract it. So we do cross multiplication. 1 times x here will give us, and then that of 12 also multiplied by cos 60 will give us what? We know cos 60 is half, and so half times 12 is 6. Or just use calculator to punch 12 cos 60, and the result will give you 6. And so that is the answer, and how we calculate for a missing side if an angle and a side is given. With this, we come to the end of this second video. This is video number 2. Watch out for video number 3 for more examples to be solved under this subtopic. Thanks so much for watching Maths Clinic series.